solutions allow us to interconnect main offices with branch locations, among other things, and that allows us to share resources. We can share access to centrally located data, services, or applications. Traditionally, dedicated circuits have been used to achieve this connectivity, things such as frame relay or MPLS. Although these provide reliability and security for the connection, our modern networks require some rethinking of this. Cloud usage, as we know, is on the rise, so we need ways to simplify the management of wide area networks. We also need a way to include our cloud resources. More and more enterprises are using cloud-based storage, and that's why SDwan is also on the rise. SDwan stands for Software Defined Wide Area Network. As the name suggests, this uses software to control and to manage the interactions between branch locations and our central resources. When we're looking at the function of SD-WAN, one of the big advantages is that there's no longer the need for backhauling your traffic. And when we say backhauling your traffic, we mean that historically with these dedicated circuits, traffic would have to go from the branch back to the main site, no matter what type of traffic it was, whether that was WAN internet traffic, whether that was traffic destined for shared resources, whatever that is, all the traffic was backhauled over that WAN connection to the main office. So that offers the potential for saturation of the WAN connection. Instead, we want to look here at what SD-WAN allows us to do. If we take a look at a very simplified topology, we can see that we have a branch location connected over an MPLS circuit, which is a traditional WAN connection method, that's connected back to a data center. At the data center, we have some advanced security and inspection happening. So that's why we would tunnel all of our traffic from the branch back to the data center for inspection. Now, in this traditional WAN setup, all of the traffic from the branch is backhauled to the data center for those security services. That includes traffic destined to the cloud or the public internet and traffic destined locally within the organization as well. So as we mentioned, and as you can probably imagine, this can cause a myriad of performance issues and delay. Depending on your circuit speed, it can cause some bandwidth issues on the MPLS connections. SD-WAN addresses this by its ability to interact with all kinds of cloud applications. More and more, our applications are going cloud-based. Think of how cheap and easy AWS storage is now, and how Office 365 has turned to a cloud platform for enterprise email access. SD-WAN can easily interact with applications like AWS, Dropbox, Azure, Office 365, and many, many more. So this means that hosting applications in either public or private clouds will allow direct traffic between the cloud application and the branch location. It will allow that rather than backhauling all of the traffic through a central data center. So that's a big reason that we're moving more and more toward SD-WAN. SD-WAN solutions can intelligently control the path of traffic in order to optimize traffic flow and to reduce unnecessary bandwidth in our networks. Now, you might be wondering, what happens to the security inspection services, since that traffic is now not being routed through the data center any longer? That's been addressed as well, because most SD-WAN offerings now provide end-to-end traffic encryption and inspection. Additionally, more and more next generation features are being added, things such as anti-malware systems and botnet intervention, many features that you would see on next generation security devices. Another big advantage of SD-WAN solutions is that they provide traffic transport independence. And in order to understand that, we need to understand the difference in an overlay network and an underlay network. An underlay network is simply the physical network infrastructure responsible for the delivery of packets. We see that here in this example. We have several sites and a data center, all interconnected by physical infrastructure. That is a type of overlay network, and overlay networks are simply a virtual network built on top of an underlay network, or built on top of the actual physical infrastructure. Overlay networks aren't anything new. Those have been around for a long, long time. Overlay networks even include things like voice over IP or VPNs. Those run on top of the internet as an overlay. With SD-WAN as the overlay network, this gives us transport independence. And by this, we mean that our WAN connections can be made up of all different types of connection combinations. We might have some LTE connections, we might have serial connections, wireless connections, satellite connections, MPLS. It doesn't matter what's running as our underlay network, because SD-WAN solutions can very intelligently and coherently choose the best data path transmission. And that's great news for us as network administrators, because it simplifies our job even further. Now that we understand what SD-WAN is and why that's being increasingly used in our modern enterprise networks, in our next video, we want to take a look specifically at Cisco's SD-WAN solution and how we would see that commonly implemented in an enterprise network.